to group, create. We're going to enter hex 20 for new group name, then we're going to click apply and cancel. Hex 20, apply and cancel. And we're going to geometry transform solid translate. And in direction vector, we're going to write 1500. Then we need to select all 10 solids and click apply. In solid list, we're going to select all 10 solids and click apply. Then we're going another time to group in post, and then we're going to click select all. Group, post, select all. And then we're going to apply and then cancel. And we're going to specify front view, and then we're going to click fit view icon. Front view and fit view. We're going to reduce the point size, and we're going to turn off the label control. So now you should see these 4 groups right on your screen. Group hex 8, group hex 20, group Z4, and group Z10. Now we're going to create a coordinate system. We need to create a cylindrical coordinate system for the hex 8 model. This coordinate frame will later be used to apply a radial pressure. It is not necessary to create coordinate frames for the other models using these steps, because this coordinate frame will later be translated to the other 3 models. First of all, we need to go to geometry, create chord 3 point. So geometry, create chord 3 point. In type, we're going to choose cylindrical, and we're going to select 3 points as indicated. This point, and this point. We're going to make sure that cylindrical is selected. Auto execute off. We're going to choose the 3 points that we already mentioned you. And then you're going to click apply. Now we need to isomesh groups hex 20 and hex 8. Mesh solids for the hex 20 and hex 8 groups using isomesh. We need to go to group post, then we're going to select hex 8 group, post, hex 8, and we're going to click apply. In elements, we're going to create mesh solid. So we go to meshing, create mesh solid. We're going to choose hex, isomesh, and hex 8. And we need to remove check for automatic calculation and enter 0.5 for global edge length. Then we're going to select the hex 8 geometry and click apply. And we need to repeat steps A through G, posting the hex 20 group, selecting the hex 20 instead of hex 8 for the topology, and applying it to the hex 20 geometry. So basically you have to do the same for hex 20. Now we're going to TED mesh groups TED4 and TED10. Now we need to create the final 2 meshes for the remaining models. This time the TED mesh will be utilized. We need to go to group, post, then select the TED4 group. Okay, well, I didn't create it because I don't have the piece. I forgot to create the TED4 group, but now it is right there. So we're going to group post TED4 apply. Then we're going again to meshing, create mesh solid, TED mesh and TED4. And we're going to select the TED4 geometry, solid 35 to 38 for the input list, right here. And then we're going to remove the automatic calculation, and we're going to have the value of 0.5. And we're going to click on assembly parameters and click on match parasolid faces. Assembly parameters, match parasolid faces, and we're going to select again the TED4 solids. Then we're going to close and apply. And we need to repeat these steps from A through K, posting the TED10 group, selecting TED10 for the topology instead of TED4, and applying it to the TED10 geometry. Now we need to observe element-free edges of mesh solids. We need to post all 4 groups and observe the element-free edges. We need to go to group, post, select all 4 groups, click apply, and then cancel. So group, post, select all, apply, cancel, verify element boundaries, meshing, verify element boundaries. We're going to click apply and observe the free element edges of the meshes. This can be easily remediated by equivalencing the meshes. So we're going to equivalence all tolerance cube. And here we're going to click apply, and then we're going again back to verify element boundaries. We're going to click apply, and we're going to see the difference after we have made the equivalence. After we have made the equivalence, the elements are connected and the only yellow lines are for the desired free edges. So now we need to copy coordinate system. In order to create the loads and boundary conditions, the cylindrical coordinated system for the Hex8 model must be translated to the remaining models. We need to go to geometry, transform, code, translate. Then we're going to 1500 in direction vector. We need to select chord 1 for coordinate frame list. Auto execute off. We're going to repeat steps A through C for creating chord 3 and 4 using 0, -10, and 0 for direction vector. And selecting both coordinate frames, chord 1 and chord 2 for the coordinate frame list. Right here. Then we're going to click apply after we have done all those changes. Now we need to create fields for loads or BCs. We need to create a field for each pressure loading. We need to click on the smooth shaded icon in order to see it with another display. Then we're going to fields, create spatial PCL function. Now we're going to create a spatial PCL function. Is in properties, fields, spatial PCL function, and we're going to enter scene pressure Hex8 for field name right here. Then we're going to select chord 1 for coordinate system. Well, I have an error because, first of all,